Hi everyone, my name is Kyle, and today is a very special day. As of this recording, it is August 30th, 2018, and in my hands I have my very first notebook, my first physics class notebook in college. And if you look at the first entry, it dates August 30th, 2013. So as of today, it's been officially 5 years since I took my first physics class in college. And in this video, I just want to talk briefly about what this class was, how I fared in it, what I learned from it, and how it sort of sets you up to do the future physics in your future courses. So first off, what exactly is this course? So for most people entering college, if you're taking the very first physics class that you can take, it's most likely going to be a class based on Newtonian classical mechanics. So in that case, you'll start off doing kinematics, where you have balls traveling with certain velocities, people throwing balls up to a certain height, and you have to calculate various properties like how long will the ball take to fall down, or what was the acceleration, or what was the final velocity before it hit the ground, those kind of problems. And then you move on to Newton's laws, so you have like F equals ma, you sum up the free body diagram, you sum up the forces in a free body diagram, and then you just sort of, use some algebra and solve for some unknowns in your problems. And then it gets a little bit harder towards the end, where you transition into rotational stuff. So you're going to be looking at like rotational kinematics, so things that are like rotating in a circle, and torques. So torques are just the rotational analog of forces. So just figuring out how much torque it takes for something to rotate, and then figuring out, what's your lever arm, or what other properties you have, or what's the inertia of the rotational inertia of the object that's rotating, those kind of problems.
Okay, so we're going to go into my physics notebook here and just take a look at some of the pages and some of the topics we covered. So the first page, we have units, and I already see a mistake there. Velocity is not meters per second squared, it's meters per second, so that's kind of embarrassing. But we just do some multiplication division with numbers with decimals. Then over here, looks like we just get into the one-dimensional kinematics. On this side, we start talking about instantaneous velocity. So moving on, so we have some more kinematic stuff. Even more kinematic stuff. So a lot of kinematics, and then I think we finally will get to Newton's laws in about like 2 pages or something. And nope, we talk about vectors. So yes, vectors, another very important topic in physics. And we're just talking about the different ways of adding vectors, subtracting vectors, finding the resultants, stuff like that. 2D kinematics, and we are just really emphasizing the kinematics here, but we have pictures of balls traveling at certain initial angles and velocities. We have hopefully we get to Newton's laws eventually. I think I skipped it, so I'm gonna go back here. Looks like we finally get to Newton's laws in this section. Right, so Newton's laws, right, forces, F equals ma. So here's like a free body diagram of trying to solve for acceleration in a certain direction. Here we go, block on an inclined plane, classic, more free body diagrams. Work, a very important concept. I feel like all of these are very important concepts. These concepts, I think, sort of lay the foundation, right? You hear these words over and over again in your physics education. Now I decided to finally go into color here, and I had an exam apparently on October 14th, so I was kind of scared for that. But energy, another very crucial concept you have to know. And I think we end with, I don't want to go through the whole thing, but I think we end with, we have simple harmonic motion, interestingly enough. And we have wave motion, and we have some Bernoulli, so fluid mechanics. So we covered a lot in this course, but again, I think it was very helpful, and this sort of introduces you to all the physics you're going to see in the future.
So if I had to say one thing about this class, I would say that the teacher he made this class. He was a great instructor at the university I was at, and he made learning just really fun. He was really funny. He broke down every problem really simply. He didn't make physics look hard, and I think that's the important thing that physics instructors need to do, is not to make it seem impossible, because I believe everyone can do physics if they really put their mind to it. And in this class, I had already seen a lot of the stuff in this class in high school, and even though I'd seen some of the stuff in high school, I was definitely not mature in the way of going about solving physics problems in high school. So what I mean by that is I wasn't really taking care of my units. I didn't always, label everything correctly. These sort of things are very important. They're the fundamentals, right, when you're starting a physics class. And I'd say it's very important to get these things right as soon as possible, because by this point in college, it was actually my third physics class. I took 2 in high school, and it was sort of the third time seeing the same sort of material again, that I finally decided to be mature about and be like, okay, I'm going to write down everything in great detail. I'm not going to write down numbers in my equations until the very end. Those sort of things are important when you're learning about physics, and I think the sooner you do it, the better, because it really shouldn't take you 3 courses to get there like it did me. So that's one piece of advice I can give, is just get good at doing the fundamentals right at the beginning, because it's going to hurt you moving forward. And I think this class, now we're going to talk about moving forward, I think this class just sets you up in the sort of the thinking about physics. It really helps you start thinking about, estimating and sort of just using the physical principles that you learn to make, educated guesses and answers to the problems you're solving. With physics, every problem can be kind of different, and you have to sort of just think about the physical principles in every problem and how you can use the physical principles and the equations that you know to get to the final answer. And it's this sort of every problem is different that sort of frustrates a lot of people. But I think it's kind of fun, because every physics problem is just kind of like an adventure, and I just love to take it on and just try and get to the end. So as sort of moving forward, I mean, this was the very first physics class. I would say by far it's the easiest physics class after 5 years of having physics. This is definitely the easiest class, but it's definitely something you need to take seriously, because if you don't take this seriously in the beginning, everything is just going to get much harder. So the next class after this, which I'll talk about more in detail in a future video, is the electricity and magnetism course. And that course is just very conceptually just really hard, because the math is hard, the concepts you're learning you're not familiar with in everyday life. And that's the benefit about the first physics class, is that you can actually sort of visualize these things in your head. You can sort of think, okay, if I throw this ball this fast, or if I push something this hard, what do I think is going to happen? And these are things that we sort of have somewhat day-to-day experience with. So that's sort of the important thing. Get ready to lose that moving forward, right? This is probably one of the few courses where you can actually use your everyday intuition of stuff that you know really well to succeed in. And that's not to make people scared, but that's just, physics is hard and it's abstract, and we don't always have day-to-day intuition about things that happen in the physical world. The best example, I think, is quantum mechanics, and we just absolutely have no physical intuition about that at all. So, yeah, I think that's what I really want to emphasize about this course. It's really important to take it seriously. It's really important to take your time, but also do your best to do every problem as perfectly as you can, because building the good habits sooner is just going to translate into an easier time when the material gets harder. So this is a great class for you to practice the fundamentals and just really master the fundamentals. So I hope you enjoyed this video. If you could, please leave a comment on the video and just talk about what was your first physics class like in college. Was it good? Was it bad? What made it good or bad? And how many years are you into your physics education now? So until next time, see you later.